Welcome to qnawire.
This question, we are given a system of elevator in which we have a spring balance in which some two blocks are connected with a pulley and string. The elevator is going upward with an acceleration of g by 10. We have to find what is the reading as shown by the spring balance. So as we know that a spring balance always measures the mass of an object. So we have to find basically what is the mass of this system as shown by the spring balance. Okay, if T is the tension on the spring of the spring balance, then the mass as measured by it is M equals the tension force on the spring balance divided by the gravitational acceleration g. Okay, so we have to find what is the tension force first on the spring of the spring balance, and if we can find the tension force, then we can easily find the reading of the spring balance. Let's say A is the acceleration of this 1.5 kg mass, and as you can see 3 kg mass is more than 1.5 kg mass, so 1.5 kg mass will be moving upward with an acceleration a, and the 3 kg mass will be moving downward with an acceleration a. This is the acceleration with respect to elevator. So we will write A is acceleration of blocks with respect to the elevator system, or simply the elevator. Okay, with respect to elevator, as the elevator is having some acceleration g by 10 upward, so then on this 1.5 kg mass a pseudo force will be acting downward, that will be 1.5 into g by 10, and on 3 kg mass also a pseudo force will be acting downward, that will be 3 g by 10. In addition to that, on this 1.5 kg mass, its weight will be acting downward, that will be 1.5 g. The weight of 3 kg mass again will be acting downward, that will be 3 g. On the string which is connecting this 3 kg and 1.5 kg block, on that there will be some tension force, let's say that is T prime. So as we know, in an inextensible string the tension force never changes, so on 3 kg block also the tension force will be upward, that will be T prime. Now if we apply Newton's second law with respect to elevator's reference frame, then for 1.5 kg mass I can write that the net force is acting in the upward direction, that is T prime minus 1.5 g plus 1.5 g by 10, that has to be equals to mass into acceleration, that will be 1.5 a according to Newton's second law. Let's say this is my equation number 1. Okay, for 3 kg mass, we can write a similar equation. In this case the 3 kg mass will be moving downward, so the net force will be acting downward, so net force is 3 g by 10 plus 3 g minus T prime, that is going to be equal to 3 times a according to second law once again. So let's say this is my equation number 2. By multiplying 2 with equation 1, we can write from 1, we can write by multiplying 2, we can write that 2 T prime minus 3g plus 3g by 10 is going to be equal to 3a. So let's say this is my third equation. Okay, so now by adding 2 and 3, by adding 2 and 3, we get t prime equals 6a. Okay, we got t prime equals 6a. Very important information we got. T prime equals 6a. Let's say this is my equation number 4. Then, so from equation 2 we will get that if I put the t prime value 6a, we will get 9a equals to 33g by 10, and on simplifying this we will get a equals 33 into g is 9.8 by 9 into 10. So on simplifying this we will get a equals 3.59 meter per second square. Then from 4 I can write that tension force on the inextensible string is 6 times a. We got 3.59. so on this simplifying this we will get t prime equals 21.55 Newton. Okay, now by drawing the FBD of pulley, as you can see the net downward force on the pulley is 2t prime because of the two side of the string. The net downward force will be 2t prime, and that net downward force has to be balanced by net upward force on the spring, that is the tension force on the spring, T, right? So then we can just write that T is equals to 2t prime. So we will get T equals 2 times what the value of the 2t prime is 21.55. so 21.55 Newton. So this will give me T equals 43.5 Newton. Then the mass of the system as measured by the spring balance, I'll write the mass as measured by spring balance M will be equal to the tension force divided by the value of G. So it will be 43.5 divided by G I have taken as 9.8. so this will give me approximately M as equal to 4.4 kg. So this is the answer for this question.